Hello, everyone. Good morning, good evening. Welcome back. Welcome to Cloud and DevOps Batch 58. Before I start the session, I just want to give a quick recap on what's been covered in the previous session. Previous session, we were discussing about various concepts in Kubernetes, and after that, we dealt about networking. And then once the networking is completed, we discussed about the non-technical aspects of how work happens within the industry, just like how day-to-day tasks will be delegated to the team and how teams comes to know who is working on whom. And we also discussed about who is a scrum master, is a product manager or the product owner, who are the teamers, who is a scrum master, all these things we have discussed. Okay. Now, the next important concept we want to talk is let's go to learn Kubernetes itself. Okay, we'll shift our attention back to Kubernetes. Just for the heck of it, I have introduced uh, the concept of networking and agile versus Scrum. Okay, Scrum versus Kanban. Ambit, I could see your hand raised. Would you like to talk about anything? Hello, Ambit, can you hear me? Hello, hello, Ambit. Anyone? Can you hear me? Check, check.
Yes, Manoj, you're audible.
Okay. So next concept I want to talk about auto scaling. Okay, this auto scaling I'll talk later, not today, tomorrow. So the idea is okay, whenever pods okay go for unscheduled state, okay, auto scaler should create another node, okay, and whenever there is no node, it should get down this. For this to work, we need to deploy auto scaler, okay, and for this auto scaler, we need to attach the rules. IAM role. Okay, that's where there is something called as open ID connectivity based authentication comes up. It's a little tricky and different concept, so we'll talk about that tomorrow. Today I'll be talking more about scheduling. Okay, let's talk about scheduling. This is also a very nice and important concept. Okay, by default scheduling. Okay, scheduling would be done by scheduler on the control plane of Kubernetes. Okay, so Kubernetes, okay, okay, what if, okay, what if you don't want pods to be scheduled on a specific or specific set of nodes? Okay, what if you don't want to be on the top of specific set of nodes? Okay, okay, I don't want on one particular node, I don't want my pods to be scheduled. Okay, what if I want my pod X? What if my pods of deployment X and Y should be deployed on the same node? Okay, let's say we are having node 1, node 2, node 3, and out of that I want to make sure I want my parts of my deployments X and Y should be deployed on the same node. Maybe this X and Y are the deployments are, let's say they work very close to each other, and keeping the latency and performance in mind, I want the pods of the deployment X and the deployment Y should be deployed on the same node. Okay, similarly, what if my pods of deployment X and Y should never ever be deployed on the same node? Okay, that means wherever deployment pods of the deployment X are there on a node, on that particular node, I don't want my parts of the deployment wise should be deployed. This is on the condition. Okay, so what if I want my pods should be deployed on the nodes at a balanced level, at a balanced aspect per zone to keep the high availability. Okay, so rather than just deploying everything on the top of a single node, I want to make sure whatever the pods that I schedule as a part of my deployment should be distributed across the zones. Okay, how do I do that? Okay, how do I do that? Okay, talk about it. And also, I also want to talk about what if you have parts of important important application versus parts of low priority applications. And would like to make sure parts of high priority should be taken into consideration first. Okay. What if low priority parts and if you schedule high priority parts and if resources are not available to accommodate high priority, should be. How can we do that? Okay, that's where pod priority and preemption comes up. Let's talk about all these things. Okay, so any questions, anyone? Okay, we talked about all these concepts and in scheduling basics we didn't discuss, taints and tolerations we didn't discuss, topology, spread constraints, pod priority, evictions. Okay, let's learn all of this. Okay, taints, concepts. Okay, taints, tolerations, node selections, pod affinity, pod anti-affinity. Again, these are these I can say you can just go through, but just want to take a moment to explain this. Okay, topology constraints and pod priority, preemption. Okay, let's try to target these concepts. So all these activities, okay, all these activities, all the below activities, below topics are to make sure how and where scheduling should be done by the scheduler. Okay, these are all the rules that we are going to tell. Okay, Kubernetes. Okay, so these are all the things that we are telling the scheduler how to schedule the pods. Okay, any questions on this, anyone? You should have a clear understanding of why are we doing it. If you're clear, we are good. Okay, all right. Now if let's go with node selector. Okay, now let's go Okay, let's say okay, let's say you are having 3 nodes in the Kubernetes cluster. Let's assume node 1, node 2, node 3. This is an AKS cluster, and this is node 1. Okay, now here I want, whenever I make any sort of deployment, okay, for example, if I was to say the deployment A, so the ports of A001, okay, AXXX, okay, so what I would like to do is I want to make sure all the parts of the deployment, okay, I want to make sure everything should be deployed on this or this. Okay, how can you do that? Okay, typically there is a concept called as a node selector. Okay, so node selector, okay, again it goes by labels and selectors, but at the node level, using this node selector, okay, we label the node saying that, okay, app is equal to X, app is equal to Y, app is equal to Z. Now while doing the deployment, we'll say, okay, go ahead and do your pods deployment should be, or do the pods, schedule the parts of the deployment A to be only on the node that has the node selector as app as A. That way we can mention the pods as well to override. Okay, why do we even need to do that? Okay, for example, you have 2 node pools. Okay, so why do we even need to do that? Okay, so what could use cases? Okay, use cases, let's say you have 3 types of nodes on the cluster that has SSD disks, HDD disk, and flash drives. Okay, now using this node selector concept, okay, certain applications like database applications which needs high throughput, that way I would like to schedule my pod to be deployed on the nodes that have this. For example, there are some applications that performance doesn't matter, then I would like to deploy my pods on the top of this HDD disk. So all the nodes that belongs to this or this or this, we label them accordingly. While doing the deployment based on the performance it need, we are going to deploy them either on this or this or this. Okay, you might not be using this on a day-to-day basis, but if you are working for any bigger companies where you are a part of the product development, okay, then where you are dealing with the multi-tenancy customers, okay, then all these things comes up. Okay, where high-paying customers should get higher performance, low-paying customers, okay, people usually when you're offering business, you offer tiers, gold class, silver class, and platinum class. Okay, based on the performance you need, you offer the resources, and there based on that, you'll be given billing. Any questions on the use case? Okay, before even I proceed further, I want to make sure you're very much clear the use case. How many of you didn't understand this? How many of you didn't understand this? Anyone?
Yes, understand, Manoj.
Okay, what did you understand?
Actually, we can offer as per the customer requirement. We can offer the resources as per customer requirement, what they are paying, what plan they have taken.
Okay, that means you will be having a free hand. Can we
Yes, we
consider
can
that?
utilize application to run as per their importance, actually,
Exactly.
critical.
Okay, based on the okay performance. So you can use the constraint pod that is restricted to run on a particular node or nodes to run on a specific nodes. Okay, using this node selector, you can assign the labels to the nodes and you can tell the deployments to run on this. Okay, let's start with the node selector. So node selector is the simplest recommended form of node selector constraint. You can add the node selector field to your specification. Okay, typically in the organizations, how we organize the resources is, for example, if you assume, okay, let's say, you can have more than one node pool, right? Okay, let's say this is one node pool and this is another node pool. Okay, so let's say this is one node pool and this is another node pool. What happened? This is one node pool. You can have more than one node pool. Okay, okay, either you can mention the node selector at the node pool level or at the node level. So if you do this, what happens is, let's say all the nodes that have SSD disk can be here and all the nodes that doesn't have SSD disk can be here. So this is like node pool HDD. Okay. Okay, this is one way. Okay, let's try to see with an example. All right. Yeah, let's do it. Maybe what I can do is I have two nodes, right? KC get nodes. So yeah, so what we can do is, so this shows what are all the labels that are available for this. Okay, so by default for each and every node, there are labels that are already assigned. Okay, if you see this, okay, so there is a Kubernetes.io, topology.kubernetes.io. This says where it is scheduled. You can see topology.kubernetes.zone. This node is scheduled on zone 1A. And if you see this, this node is scheduled on the zone 1B. Okay, so that means Kubernetes is already smart. If you just say, because I have already mentioned I want two nodes, so it didn't just schedule it on one zone or two. Okay, so since you mentioned two zones, it scheduled one node in each and every zone. So it makes sure a single point of, for example, if there is a zonal failure, your application will still work because your resources are going to be scheduled on two nodes that are in two different zones. Okay, so whatever the labels that are already been there, you can also get that. So the command to get the labels is kube control get nodes. Okay, so this is how, okay, you can label the nodes. How to see the labels. Done. Next. Next, I would like to, what I would like to do is I would like to label my node. So how can I label the node? Okay, so here, I think here in the have mention kube control label nodes. Okay. Add label to a node. Hmm, where is that? configure pods. Go to tasks, configure pods and containers. Underneath that, assigning pods to nodes. Mm. 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 So here, assign pods nodes. Assign pods to nodes. Okay. Okay. So here, you need to have a Kubernetes cluster. Yes. So keep control get nodes. Yes. And this is how you can label the node. So we are just labeling the node. So what I would like to do is I want to make sure I will label my node. Okay, this is my node. Okay, node number 1. Okay, what I would like to do is what I would like to label is not label. Okay, disk is equal to SSD. Let's say let's go with this. Okay, other one 170.31 39-2. Okay, now disk type is equal to flash. Okay, disk type is equal to SSD, disk type is equal to flash drive. Now I have labeled these two nodes. How to label the nodes? How to label the nodes? Done. Okay, now here if you see show labels, you see the labels that we made. So what were the labels that we have made? Disk type is equal to flash drive, disk type is equal to SSD. Now we have a control, we can mention where the pods to be scheduled. Now without using anything, we'll try to deploy. Okay, so for example, I have my pod, right? So what I can do is, this is my pod. Okay, this is my pod. Not pod, let's go with the deployment. This is my pod, right? So what I'm going to do is I would like to cd kc apply -f001 pod, right? Now come here. This randomly gets deployed, okay? You don't have any control. So kc get pods -o wide, right? Now it has deployed on the top of the, okay, on the top of the keep control gets. Okay, if you look at this, where is that? So here my pod is deployed, kube control get pods -o wide. And if you look at this, my pod is scheduled on the node, okay? And it is scheduled on the node that ends with -2. So my pod is scheduled on the top of the node whose disk type is flash drive, right? Now I'm very specific about it. Now if you try to delete the pod, kc delete the pod, exp pod. Okay, again, if you try to schedule it, that means nothing but apply the pod. Now again, if you try to see this, it will be deployed elsewhere. Okay, and this time it is scheduled on -2. Again, it has the schedule on the top of the flash drive. Now I want to make sure I want this pod should be scheduled only on this particular node that has the tag as disk type is equal SSD. Okay, disk type is equal to SSD. So what I'm going to do is I'll try to delete the pod. Okay. Now, as per this, the node selector is equal to SSD. Okay. This is at the container level, by the way. Okay. This is at the pod level. You need to be very, okay. You cannot say, I want container 1 of the pod to be scheduled on this node and container 2 of the pod to be scheduled on other node. It will not work that way. Can anyone tell me why? Because you're scheduling the pods, okay, not the containers. Okay, that's the reason it is a container level, it is a pod level resource. Now I have mentioned the disk type as SSD. Okay, now publish it. Now make it apply. Okay. If you see this, it's gonna create the pod, get pods. You can see it is going to be scheduled on the node, which is nothing but 19. Because this, I have mentioned, I want this to be scheduled on the node of the Kubernetes container, Kubernetes cluster that has a node whose label is disk type is equal to SSD. And if you come here and if you try to see this, and it is going to be scheduled on the node that has disk type as SSD. Clear? Okay. Now what I would like to do, okay, just copy this node selector. For example, 24. Okay. Node scheduler. All right. Now, another thing what I would like to do is I would like to go with the deployment. Guys, let me be very clear, very clear. If you don't know Kubernetes, there are very less chances you get interview calls. Okay. In the previous batches, we were not covering Kubernetes to this much extent. Rachit, you are aware of this, right? So we were not covering Kubernetes to this much extent. The only reason why we are covering Kubernetes to this much extent, though the course is getting delayed, is because outside in the market from last 2 to 3 months, jobs are really less, really less. Okay. So they're scrutinizing the people and they are making sure people with the right skill set and right basics are being hired, because people are more right now and the positions are less. So they are really looking for skilled people, and that too, Kubernetes and Terraform are must. Rachit, you are aware we have not included this much context in the past. Are you there?
Yes, Manoj.
Okay.
Yes.
So the state toleration, stateful set, okay, a few other concept quotas, okay, VPS, network we were not covering. Okay, we are telling just go through it. The only reason we have included all this is because of the market. Okay, so yesterday I got 2 to 3 complaints saying that, Manoj, when we started the course, you promised that it's going to be completed in 3.5 months, but now you said that it's going to take 2 more months. Okay, I have added really a lot of topics. Okay, hope you guys are okay, because November, the only reason I have taken this is, however, in November, December, there are really less calls. Okay, so rather than me just selfishly covering the course, I'm okay to extend 1.5 month. Okay, you guys are okay, Srilata, Mridula, because we are go through this everything one more time on other project as well. So that means we'll do 2 projects. Mridula, Harish, Shailaja, you guys are okay if we do one
Yes,
more
Manoj,
project?
it's
Yes,
fine.
Manoj.
Yeah.
Okay. So
Yeah.
initially I thought of going through one project only, but however it is December, right? So that's the reason I just want to take that decision. Again, it's in favor of you. Okay. If I complete the course in November itself, I can start one more batch, I can more more money, right? But I just refrain myself because I focus more on product quality than just quantity. Okay. All right. So let's do one thing. What I'm going to do is, okay. The reason why I'm saying is just make sure you focus more. Okay. That's the only thing that I have. Now I want all the parts of this should go and deploy flash drive. Okay, now where this flash drive is, now whatever the number of ports that I schedule, okay, it is having the disk type as flash drive, which is nothing but the node that ends with 39.2. So what I'm going to do is I'll publish it. GB CAF. Okay. Okay. Now get pods. You can see all the 3 nodes are deployed on the node that ends with 39.2. And even if you scale it, case is scale Nginx deployment to -1 replicas is equal to 10. Even if you scale this way, and all of them will be scheduled on the same node. Okay. Typically, you don't just taint the node because when the cluster scales up and down, this node will be gone. So typically, you label at the node pool level. But for the demo purpose, I'm just using it. But fundamentally, the concept remains the same. If you look at it, all the parts are scheduled on the same node. Okay, because this is the only node that has a flash drive. Okay, what if your applications are gaming applications that needs GPU? All right, that's the crux of it. Any questions on this? Okay. Okay, so using node selector, you can define where to schedule the parts. Okay. How can we make sure that parts should not be scheduled on the nodes of our choice? Okay. Okay. So let's say you're having these many nodes. Okay. Node 1, node 2, node 3, node 1, node 4, node 5, node 6. I would like to do maintenance on this node and this node. Okay. Or this node and this node, I don't want to schedule nodes on the top of it, pods on the top of it. Okay. So that means whenever Kubernetes scheduler schedules any sort of pods, by default, it should not be scheduled on the top of the node 3, any pod. But whenever I wish to deploy anything on the top of it, we should be doing it. Okay. How can you do it? Okay, let's talk about that concept. And that's where we have a concept called as a taints and tolerations that comes up into picture. What is taints and tolerations? Taints and tolerations are used in Kubernetes to restrict or allow pods to be scheduled on a certain nodes based on labels. If you taint a node, okay, taint, okay, let's assume it like a taint. Okay, taint, paint. If you taint this node, okay, just for the purpose of memory, I'm just saying I'm painted this node. If you paint the node, pods won't be scheduled on it. If you don't, okay, if there are any paints, okay, which is nothing but taint available on this, nothing will be scheduled. Assume taint is just like a paint. When you paint a floor, it will be wet, right? So when the floor is wet, we don't use it. So likewise, when you taint a node, we should not, okay, Kubernetes scheduler will not allow the pods to be scheduled on the top of it. All right. Clear, guys? This is the purpose of it. Any other questions, anyone? Any other questions, anyone? Are we clear? We know where to schedule the pods. We also know how can we make sure we don't want those pods to be scheduled on these nodes. Okay, this is another way. All right. Okay. So, so a taint is a label. Again, a taint is not something really paint where we paint it with a brush. A taint is just a label that is applied on the top of a node to indicate certain limitations or requirements. Okay, if you so the moment you taint a node, by default, your Kubernetes scheduler won't schedule pods on the top of that particular tainted node. But if you forcefully wish to deploy any pod or schedule any pod on the top of the node that is tainted, you need to use tolerations. That means if the floor is painted with a paint, if you want to touch it, you put some gloves and touch it, right? So like that, if you want to schedule a node deliberately on the top of the node that has a taint, then you need to use a toleration. Okay, so a toleration is again a label applied to a pod to indicate that it can tolerate to the label. Okay, it can tolerate to the taint. When a node has a taint, only the pods with the corresponding tolerations can be scheduled on that node. This feature is useful for various purposes, such as ensuring separation of critical and non-critical workloads, receiving nodes from special tasks. Okay, if you want to go with official documentation, this is how it looks like. Okay. Taints and tolerations. Okay, so how do you taint it? So you can taint the node sweep control, taint node. Okay, node key one is equal to, again, there are three types. Okay, so there are three types of taints. Okay, so taint. Taint is a feature that allows scheduler not to schedule pod on the node that has taints. Okay, only the pods that has tolerations to the taint can be allowed to be scheduled on the tainted node. Okay, now taints can be operated three modes. One is no execute. Okay, another is no schedule. Another is prefer no schedule. Okay, so this means no execute. If you taint a node with no execute, okay, it's not going to schedule. Okay, the Kubernetes scheduler will only, okay, pods will only be scheduled on the tainted nodes if the pod has taints, tolerations. Okay, if not, scheduler won't schedule. Pod. Okay, next, no schedule means, okay, no, okay, no, I was wrong. Okay, so your Kubernetes scheduler will only schedule the pods on the top of the node that has taint. Okay, so for example, you wish to deploy a pod that don't have any toleration, then it's not going to be scheduled on the top of a node that is going to have a taint. That means by default, it's not going to schedule the node on the top of the node that has this. Okay, that's what it says, no schedule. No new pods will be scheduled on the tainted node unless they have a matching label. Pods currently running on the node are not evicted. Okay, no schedule means pods will not be scheduled on the top of the nodes that has this taint, but existing pods will run. Okay, okay, next is no execute. So the moment, this is a very hard one. So there is a node that has pods running. Now you have tainted the node with no execute. Now whatever the pods that are running there don't have the toleration. So all the pods that are running will be evicted and will be scheduled on the other nodes. Pods that do not tolerate the taints are evicted immediately. So no schedule means it's just like no new pods won't be scheduled because you don't have. But no execute means it's a hard one. Okay, pods that do not have the taint are evicted immediately. Okay, it's a hard one. Prefer is just like a very soft one. Okay, new pods will be scheduled on the tainted node unless they have matching toleration. Okay, this is also okay. This is the soft version of the above one. Okay, so this is just like it prefers to schedule on the top of the node that don't have taint, but if it's not able to find anything, then it says okay. Soft version of no schedule. It prefers not to schedule on the node that don't have taints, but if it's not able to, then it avoids and it deploys. Okay, but it's not a guaranteed. No execute means whatever the pods that are running will be evicted if it doesn't have a taint. Okay, no schedule means no pods won't be scheduled on the nodes that don't have the taint. Prefer not schedule means no guarantee. Okay, most of the Kubernetes flavor taints the master node. Okay, so you might think, okay, for example, okay, so let's assume this is a master node. Okay, how many of you think pods will be deployed? Okay, not API server, control plane pod and all. How many of you think, okay, pods will be scheduled on the master node as well? How many of you think? Okay, so can anyone tell me why your workloads or the pods that you are intended to deploy won't be scheduled here, won't be scheduled on the master node? Okay, so interview question, can workloads be scheduled on the top of the master node of the Kubernetes cluster or not? What will be the answer? Anyone? Anyone? Think. Rachit, Ambit, Girisha, anyone?
We can, sir. We can deploy multiple servers.
No, listen to the question. What is my question? My question is very simple. Can you schedule the pods on the top of the master node? That's my question.
No, no, Manoj. Actually, this is master node, that is controller. If it
That's
went down, then we will not be able to manage the cluster, Kubernetes cluster.
your answer is right. Okay. The only reason why workloads by default won't be scheduled on the top of the node is because if you lose everything, right?
Yes.
Okay. And second important thing is, my question is how workloads are not getting scheduled on the top of it, because on the top of the master node, okay, it will be having a taint. Since our workloads are not going to have tolerations, so workloads are not going to be scheduled on this. But on the top of the, for example, get nodes, if you see this, do you know which is master? Do you know which is which is a control plane node? So in the managed ecosystem, okay, in the managed clusters, that means whenever you're using Amazon Elastic Kubernetes cluster or Google's Google Kubernetes engine, okay, so you never know which one is a master. I mean, you never know the master control plane or the master component. Okay, it is kept behind the hoods. You won't be having control to it. Whatever the nodes that you see are the master, are the control plane or the work, not control plane, or the data plane or the worker nodes. Okay, so you won't be given access to the control plane or the master node, because if they give access to you, if you tune something on the top of it, you won't get performance that Amazon has promised. Okay, but if you are using your OpenShift cluster or Rancher cluster or Tangua VMware cluster on your on-prem, you will be having access to the master plane as well, or the control plane.
Yes.
Okay.
Yes.
All right.
So I think in Kubernetes, customization level is very high.
Yeah, you not customization, that's not the right way. You can extend the features. Okay, for example, if you are starting a company and you want to build your own objects, just like deployment, stateful sets, okay, config map secret, just like that. If you want to make your own objects, you can do it by using operators and CRTs. Okay, yes, it is highly customizable.
Yes.
Okay, correct. So yeah, this is what it is saying. Let's talk about it. Taints and tolerations. Very nice document. Let me open this. Taints and tolerations from densify. What these guys are saying. Yeah, see, node 1 taint is equal to test, okay, and no schedule, and taint no execute. Okay, so it's not going to existing parts will be evicted, new parts won't be scheduled on the top of this node that don't have the tolerations. Okay, so use cases for taints and tolerations. If you need a dedicated group of workers for a set of workloads, you can taint them so that only the users who know this can schedule. Okay, nodes with special hardware, I told you, right? If they have special SSD disk or flash drives, so where you want to taint the node, only the workloads that really want, you'll tolerate them. Okay, so yeah, how to use taints and tolerations. Next, first you need to taint the node. So what I would like to do is I would like to taint the node. Okay. So I would like to taint the node. So keep control taint. App is equal to expense. App is equal to expense. Now what you did is you did the taint. Okay. You control show taints. How to see the list of taints? How to see the taints? Okay, if you want to see the taints, how to see the taints? How do I come to know whether it is tainted or not? How to see the taints of nodes on Kubernetes? Okay, kube control get nodes -avoid. That's what I did, right? How can I list the taints on nodes? Kube control get nodes. Okay, that means you need to describe the node. Okay. So yeah, can you see this? It has taints. Okay, and what is the taint that it has? App expense is equal to no schedule. Now if we try to do the same with 39.2, okay, now you can see there are no taints that are tainted on the top of this particular node. Okay, so that means 39.2, okay, don't have this. Okay, now 39.2 don't have the taints. So we have tainted this particular node. Now if I schedule any sort of workloads, where my workloads are going to be scheduled, here or here? Anyone? So this is how tainted the node, right? Taints. How to taint a node? how to taint a node. Okay, workloads going forward cannot be scheduled on the top of this node. Okay, now let's try to see this. What I can do is the 0 to 16s. It's about taints and tolerations. YTF. Okay, I'll say taints deployment. Okay, app is taints. Okay, taints deployment. That's it. Try to deploy it. Okay, now now I'm not going to use the node selector as well. Okay, I'm very clear on it. CAF 0 to 6. Okay, be very clear. So 39.2 don't have taints. Okay, this has 31.9. Okay, has taints. So that means since it has taints, workloads are not going to be scheduled on the top of it. Okay, CAF taints get pods. Can you see the taints? And you see everything are deployed on 39.2. The reason why everything are deployed on 39.2 are because we have taints on the top of this 31.19. Now, whatever case is scale deploy, taints deployment, and all the nodes of this taint will be scheduled only on the top of this particular node. What if I want my workloads to be scheduled on the top of the node 31.19 that has toleration? Okay, so this has taint, right? Now I want to make sure I want my workloads to be scheduled on the top of this node that has a taint. Okay, so that means my workload should have a toleration. Okay, workload with toleration. Workload with toleration. Tolerated deployment. Tolerate deployment. Okay, simple. Now let's try to publish. But how can we add the toleration? That is another thing, right? So how can we do that? So let's go here, see the example. Tolerations. Yes. So tolerate effect is equal to no schedule. Okay, because our taint is no schedule, right? So if it's not able to find, it's not going to schedule. So app is equal to expense, no schedule, right? Now here, app is equal to schedule, app effect is equal to no schedule, key is equal to app equal to schedule. So this is what the toleration that I would like to use. Tolerations, it's at a container level, right? Okay. Okay. Any questions, anyone, before I proceed further? Okay, app is equal to app is equal to expense, no schedule. Okay, so I'm telling you can schedule this pod on the top of the node that has taint app as expense. So no schedule, effect is equal to no schedule. So that means my pod is not going to be scheduled on the top of the node that doesn't have the taint this. That means my pod can schedule on the top of the node that has this. Okay, it can, but it's not guaranteed by the way. Okay, this pod can be scheduled on the top of any node. Okay, remember this point. This pod, the pods of this workload can deploy on any of the node, including the nodes. Okay, let me write this point. The pods of this deployment can be scheduled on any of the nodes of the cluster that also has stains on the node with the effect okay. All right, so let's see what it does. Okay, I told you from the beginning, none of the pods are scheduled on the top of this. Okay, so okay, see delete deploy tains. Okay, bash various tolerations. Okay, now this pod can also be deployed on the top of the node that has taints. Okay, so taints deployment. So if you look at this, taints deployment is only deployed on the top of 39.2, but toleration deployment can be deployed on any of the node, including the nodes that has taints. Okay, that's the idea. All right. Okay, clear? Earlier, whatever the deployment that you're doing, they are going only on the top of the two. Now, tolerant deployments are tolerant to the tainted nodes. So they have the privilege to be deployed on anywhere, including that nodes that has taints. Any questions on this, anyone? All right. Now, okay. So another thing, whenever you're doing any sort of maintenance, okay, whenever we are taking maintenance of the cluster, like upgrading, updating from one version to other version. Okay, for example, here, if the version is 1.29.3, okay, so this is like major version dot minor version dot service pack. Okay, so keep this point in mind. We can only upgrade from one minor version okay. An example is 1.29.3 to 1.30.01 to 1.31.0. So you can only upgrade from one minor version to other version. Okay, we can migrate, but we can move from one service pack to other service pack without any dependency. All right, and in the maintenance window, typically first master will be upgraded, and then worker nodes will be okay. In the managed Kubernetes cluster, in the unmanaged Kubernetes, unmanaged or on-prem Kubernetes cluster, if you wish to migrate, if you wish to do maintenance on the workload, okay, then we first mark that node as using an option called as cordon. Once you cordon the node, new workloads won't be scheduled. And that turns to not ready state. Okay, so get nodes. This is how it looks like, right? Okay, all right. Okay, now it's fine. Kernel version. Okay. Just remove it. All right, this is how it is, right? Now here, if you look at the status, it is in the ready state. Now, what I would like to do is, so here, what I would like to do is, I would like to cordon the node. Keep control, cordon node. This. Now, what will happen is, keep control, cordon. Okay, so this is how you can cordon the node. Once you cordon the node, what will happen is this will be turned to see what will happen. Can you see this? Ready, but scheduling is disabled. That means whatever the workloads that are running will run as is, but no new workloads won't be scheduled on this. Okay, clear. So this way we can stop running the scheduling on the top of it. So, but what if there are nodes that are already running? How can I evict them? Okay, so for example, I don't want KC get pods -o. Again, you should be very careful. That's the reason I always told you, you taint the nodes at the node pool rather than tainting the nodes at the pod. Okay, at the node. So node selector also, we don't do the taint node selections on the top of the real node. Instead, we do the node selections on the top of the node pool, because nodes always upsize, downsize, right? I mean, upscale and downscale. So here, if you look at this, I have pods that are already running on the 39.2. Okay, now if you just say, okay, if you just say these three nodes, okay, whenever you evict the nodes, okay, so these deployments, change deployments can only run on the top of 39.2. Okay, because this deployment has taints which can only be run on the top of this. Okay, so that's the reason you need to make sure you do the taints, you do the node selections on the node pool level. Okay, so keep control. There is an option called as keep control cordon. Cordon and drain. Okay, so cordon. Okay, Okay. First, we cordon the node. This disables the scheduling. Existing workloads will run as is. Next, we'll drain the node. Existing workloads as per the grace interval. They will run and will be evicted and will be scheduled as per the exceptions on the other node. Okay, so keep control cordon, you know how to do it. Drain. Drain node. Yeah, so keep control drain grace period you can mention. Okay, so if you drain a node, it gives a terminate, it gives some time saying that okay, so I'm giving you it sends a signal to the workloads that are running. Okay, I am passing a signal that you have a time of 900 seconds or 10 seconds or 30 seconds. Make sure you do your job and just kill yourself and schedule on the other node. If not, I'll kill you in 90 minutes or 50 minutes. So you can mention this. Keep control drain. Okay, you can also give the graceful period. Seconds, by the way, okay? Okay. Now you can say get pods -override, right? Get nodes. So I would like to drain this node, okay? So typically we try to cordon the node first, okay? And then no new workloads won't be scheduled, and then we drain it, okay? Now let's do it. I'm giving 30 minutes of time to drain this, okay? So what happens, it says unable to drain the node, okay, because cannot delete daemon pods, okay? We didn't talk about daemon pods. Daemon pods is just like whenever, okay, this is a very important question. Whenever you want to run one pod, for example, if you make a deployment, I wanna make sure each and every pod run in each and every node of the cluster. If it's upsizes, if it's upscales, or if it scales out to 10, 20 nodes, even on all the 10, 20 nodes, I want one part of my deployment should run. Whenever it scales down, automatically it destroys, okay? Typically, whenever you're using log extraction solution, metrics explorer, okay, that way it can extract the metrics from the nodes and pump it to elsewhere. That way you use a type of deployment called as a daemon set. Daemon set ensures, irrespective whether your cluster upscales or downscales, it ensures a single instance or a single replica of your set will be running on it. Okay, typically it will be used for logging solution, monitoring solution, and all. Okay, it says on these particular nodes, okay, there are daemon sets that are running. Okay, if you want to ignore them, okay, ignore the daemon sets, you can run this command. Okay, and unable to drain the node, cannot delete the pods with local storage. It also tells, all right. I know that we do not have any sort of workloads that has it. Okay. Can you see this? Now scheduling is disabled. It's ready. Scheduling is disabled. Get pods. Okay. Now, if you see this, the reason why, okay, taint spots are in the pending state is because that node went for maintenance. You should have another node to accept this. And these two pods, okay, the reason why they went to the disabled state is because they were scheduled on it. Okay. After some time, they will also be running to the running state. This is how we can make it happen. All right. And once maintenance is completed, so you cordon the node, right? You can do uncordon. Since you uncordon it, okay, scheduling disabled option would be disabled. Now, whatever the pods that are in the pending state in the past, they will be coming to the running state. Okay, clear? Once maintenance is completed, right, uncordon the node. Okay. Clear? Any questions on this? Okay. All right. Now, next question is, okay, now I don't want to continue with the taints. Okay, how can I get rid of the taints? Okay, how can I get rid of the taints? Now here I have taints that are labeled on the top of this particular node. How can I get rid of it? How can I get rid of it? Okay, so here the label is this, right? App, right? Now, next, how to remove the taint? How to remove that node? Okay, it's very simple. Keep control taint node, okay, hyphen, okay. This is how you can untaint it. Okay, there is no command called untaint. Whenever I ask anyone, how do you untaint? How do you remove taint? People say untaint. Okay, come here. Now see this, there won't be any taint. Okay, so yeah, this is how you can do it. Any other questions, anyone? Okay. Okay, the next concept is topology. Okay, so let's say, okay, let's try to get rid of it. Okay, let's say this node pool is a multi-zonal node pool where this is in zone 1A. Okay, by default, Kubernetes does this. Can anyone hear me? Am I audible? Check.
Yes, Manoj, audible.
Yes, Manoj.
Okay. Are we clear so far, by the way?
Yes, yes.
Okay. Another concept I want to talk is topology constraint. Okay. So typically how we design the things is, okay, we make sure the product is fault tolerant, okay, to zonal, or I want to make sure my product is okay, failure tolerant to zonal failure. Okay, for example, you have your workloads on US East 1, Zone 1A, Zone 1B, and Zone 1C, or US East 1A, US East 1B, and US East 1C. You want to make sure whatever the deployments that you do, they will be distributed equally. Okay, for example, if you say 3 deployments, okay, I want to make sure, okay, they will be, okay, so they will be distributed across. Okay, for example, if you say 6, 2 should be deployed here, 2 should be deployed here, 2 should be deployed here. Let's take this out. Okay. If you say 6, I want to make sure 2 should be deployed here, 2 should be deployed here, and 2 should be deployed here. Now, what will happen if you deploy this way? Even if you lose this zone or this zone or this zone, your application will still work. That means your application is tolerant to the fault. But how the proportion should work is something the topology constraint will decide. Okay, so let's talk about that. Topology constraint as a very important thing. Okay, but whenever you're dealing with the bigger companies where the product is at scale, then only you will talk about these things. Okay, topology spread constraints. This topology spread constraints ensures even distribution of pods across the cluster's topology. Constraint defines rules for the number of pods of a certain type that when we given, okay, that can run on a given level. Okay, that can run on a given level, such as nodes, zones, or racks. Okay, these constraints can be customized to fit the needs, such as ensuring the critical workloads are spread across multiple zones. Okay, so let me talk about this. Okay, this is also widely used, by the way. Okay, but not in a simple environment. Okay, but if you are working at environments at scale, okay, the motivation for this is very simple. Imagine you have a cluster of 20 nodes and you want to run a workload that automatically scales how many replicas it uses. There could be few 2 pods or 3 pods or 15. When there are 2 pods, you'd prefer to have both of them on the nodes on the same node, right? For a better performance. But again, if you have 5 workloads that need to be running, if you have 10 pods, typically, if you schedule all of them on single node, you might get a better performance. But if you lose that node, you're at a single point of failure. Correct? Correct or not? Correct or not, guys? Okay. So using this concept, we can make sure the pods are distributed across the zones of your cluster. Okay, this is how the topology constraint works. You have an option called as a max queue. Again, there are a lot of other options. Okay, and it may, if you ask me how your pod comes to know where it has to schedule, how your pod comes to know where this node is scheduled. Okay, if you look at this, okay, by default, all the nodes get nodes. Okay, hyphen show labels. Okay, by default, they already have the labels defining that. Okay, topology key, which is already there. Okay, topology.kubernetes.io, this defines the region. Topology.kubernetes.io.zone. Okay, that defines where it is. Okay, using this option, you can mention where it has to schedule. Okay, so 0 to 8. Topology. Okay, I'm not using any sort of tolerations. I really don't need at this point of time. Okay, now I mentioned 3. Okay, now what I want to do is I want to make sure topology spread constraints. Again, what is this max queue? Okay, so typically people go with max Q as max Q as 1. What does this mean 1? Okay, so let's say you have scheduled, okay, 6 pods. Okay, 6. So 3, 2, okay, 3 minus 2, 1. And so here other can be 1. Okay, so this way 2 pods will be 3 minus 2. Okay, 3 minus 2, 1. But 3 minus 1 is 2. Okay, 2 minus 1 is 1. But this to this is there is some difference. So what it does, it just reduces. That means it deletes 1 pod here and schedules here. But here it comes as 0. So here what it makes sure is it comes 1, 1, 3. Okay, let's see how it works. Okay, so yeah, let's see. So this topology key constraint, spread constraint, ensures the difference between the pods that are scheduled will have, okay, the difference between the deployed constraints as 1. Okay, so let's go here to the spec. Max Q as 1. Let's see how it works. Okay, so 1 is the suggested value. That means, okay, now I'll just say 5 pods. Okay, you don't see much difference here because you have only 2 nodes, but yes, let me show you. Okay, so here if you don't use this, okay, so here if you just mention, okay, let me try to take this as an example. Let's take this as an out. Okay, now if you just say 6, okay, so 6, what it shows is 6. Let's see. Even I am interested to see. So let's see topology, right? Publish it 0 to 8. Calf. Spec topology spec constraints.
Yes, there is topology actually spelling mistakes
Is it?
in code actually.
Well, this is right only, right?
Topology name that is
4, 6, 13 Manoj line numbers.
$13. Yeah.
It should be the topology, right? Everywhere it is topo or something.
But yeah, that doesn't matter. This is what it matters. Okay. Okay. Hey, okay. Sorry, guys. We are already 10 minutes on the top of the schedule. We'll see this tomorrow. Okay. Start from. Okay. We'll see this tomorrow. Any other questions, anyone? So auto scaling is a big concept. Okay. I'll see whether we can cover or not. If not, I'll just prepare the code and get back to you. Okay, because the OADC creation is almost 30 minutes. It takes 30 minutes of time. Okay, but I'll come with the code. Okay, it's just create a role and attach it. Okay, but yeah, any questions, anyone so far?
yes, Manoj. I have one question. Can we use for one single Kubernetes cluster multi-region, 2 regions?
Here is how you're talking. Let's talk about it.
Not zone. I
Yeah,
talk
hold on.
about different regions.
Yeah, no, you cannot. Okay, if your question is this, okay, typically Kubernetes don't offer a cluster that can spread across multiple regions. Okay, typically if this is your Kubernetes cluster scope is regional. Okay, EKS. Okay, your workloads can spread across zones. Okay, but whenever you land into a requirement where your workload should be specific, okay, both for zones and regions, then you create two clusters, okay, in two different regions, and you
Okay.
use a load balancer called as a GLB, okay, global load balancer. Okay, this balances the load between these two. Again, these will have a regional ILB, right?
So, what is best practice we can say? Use two zone or three zones
Three.
for a cluster?
Always odd number, no even number, okay? Always three. But if you ask me, do I need to go with a regional or not? It's your company, how much money it can pay. Okay. If you say that I want regional availability, but I cannot pay, it doesn't work. Okay.
Okay.
Everything boils down to cost. You are well aware of it, right?
Yes.
It's about you get whatever you can pay. As simple as that. Okay, but you cannot go both. Okay. Any questions? Okay, but you cannot create a cluster in two regions. Okay, that is very clear. All right. Okay, then that's it. That's for today. And we're going to meet tomorrow in the session. And thank you very much. Signing off for the day.